My name is Chris Spence. I am the Professional Services Manager for Puppet Labs here in the UK and Europe. If you haven't got my details by now, they're there. Just want to say a quick thank you to Imperial College for allowing all you guys to be here. It's kind of a special moment for me a little bit because I need to thank Imperial College for me being here at all. Because back in the 1960s, this is where my parents met. Which is
not this room.
I hope not. Okay. There we go. So before we start, I just want to do a quick poll of you guys in the room. And a quick show of hands. So everybody who's not using any kind of configuration management in their production network, can you just stick your hands up? Okay, cool. So Dawn, just keep your hands up.
Keep your hands up.
Dawn's just going to wander around with some books for you guys. It's good to know you people are in the right place. Everybody else, so I'm assuming you're all Puppet users and that's why you're here. Who's been using Puppet for more than 1 year? Yeah? Who's been using Puppet for more than 2 years? So there's still quite a few there. 3 years? Ooh, a few people there. 5 years? Boom. Sort of. Yeah. It's always interesting to get an idea of how much configuration management has grown in the industry just in a very, very short space of time. And it shows us that, there we go. I can't move too far from the computer, that's what it shows us. That we live in interesting times. Those of you familiar with the works of Terry Pratchett will know that this is an ancient Chinese curse. The curse of which is that if you're living in interesting times, it's probably a bad thing. For those of you not familiar with the works of Terry Pratchett, it's an ancient Chinese curse, showing us that it's kind of bad to live in times when things are changing too fast. I don't think that's the case. I think now is an exciting time for information technology and industry. And it's a time in which there are more services everywhere. There are more servers. And those services that are running on those servers are becoming increasingly more and more critical to the everyday running of your businesses and our business. I think it's true to say that there is no future in which IT is going to become less critical and less important to the running of our businesses. And the way that IT is running is changing. We're in a world now where there are probably people in this room that have no idea of what the concept of a maintenance window is. What's a maintenance window? That's the time when you take down your entire production network to make a change on it. And that's also the thing that you used to have to schedule some time on a Saturday night to roll back in case it went wrong. Those times just don't exist anymore. The world we're in now is a world where things are happening. There are more and more things that are happening faster and faster and faster. And the demands, the timescales over which we demand that those things happen are decreasing rapidly. The world where it was acceptable for us to wait 9 months for that Enterprise 10,000 to arrive from somewhere, that's not here anymore. We can't wait 9 months for a thing to arrive from California. It just doesn't happen. Even 3 months is too long a timescale for us to be able to implement change in our production infrastructure. So the ways in which we used to run production infrastructure, even dev testing infrastructure, now constraining us. Just can't run things in that way. It's too costly. The people factor means that the hiring of a sysadmin to curate 25 servers, we just can't do that. The meat bag automation way of driving infrastructure just doesn't actually fix any real problems. And we need to adapt to those times and change the way that we're doing things. And you can't decide not to change. You can't declare that the way we run our business is perfectly okay. It's worked up until now, and that's just going to carry on working. The classic example of this, I saw a pictorial timeline of Netflix versus Blockbuster recently, and the rise of Netflix and the demise of Blockbuster. As Netflix adapted to change, they did things quickly, they leveraged that technology, and the Blockbuster sitting there just thinking that we can't, that they're not making those changes quickly enough, they became a dinosaur very quickly. So the old ways of doing things are constraining us, and the old ways, and the constraints that were there are gone. So we don't have to wait 9 months to do these things. Often we don't have to wait 9 minutes to do anything. The rise of public cloud infrastructure, it's possible to spin up 1,000 instances of a server in just minutes. And the workloads that we run on those servers, we can move them from here to here in minutes because the technology exists to allow us to do that. And the ways in which we think about building those services have changed as well. So where our developers are adopting lean and agile practices to build our internal custom applications, that means that they're raising an expectation that they need to be able to deploy those changes much, much faster. So we need to adapt the way that we run our infrastructure to be able to cope with the rapidly changing business and technology landscape that we live in. There are a few kind of headline IT movements that have made a lot of this stuff possible. The large sets of disruptive technology and disruptive practices that have enabled this to happen. I think the biggest thing that has really made all of these changes has been the presence of cloud. So players like Amazon have entered the marketplace, and we don't need to buy servers anymore. We can just shift our workloads out of the cloud and we're there. And that's had a huge disruptive effect in the last 10 years. And movements that affect the way that we run our internal businesses. So DevOps as a thing has changed the way that organisations collaborate within themselves, and has brought different ways of managing our infrastructure. So I'm a recovering sysadmin, and the lessons I've learned, even in the last 2 years of being in Puppet Labs, from hanging out with developers and taking those processes that developers use, so leveraging things like version control and thinking about being able to test your infrastructure, make a huge difference to the way that we can visualize and manage our systems. So there really is no future in which there are fewer servers, or fewer services, or the things that run on them are less. And that goes right from the bottom of your stack. So just pure, trivial IP services like DHCP and DNS. The ways that those things run on your networks become incredibly critical to the operation of it. Even something as simple as time becomes increasingly critical, and the ability to be able to manage that service on your network becomes much more important. So, in a lot of ways, the software as a service industry is setting trends for what we're doing. Quick ad hoc poll now. Who still runs their own mail infrastructure within your organisation? That is less than half of you. And thinking back 10, 15 years, that is an incredible number. Mail used to be a thing that every single enterprise seriously cared about. We're going to run our own mail infrastructure because it's important to us. And what software as a service has shown us that things that are important to us can effectively be outsourced. And I think there's some interesting lessons around that, the way we treat the concept of those kind of services. And I think the message here is that those things are services, and you can pick them up and you can move them out. So email is a thing. Puppet Labs as an organisation, our core business is software. we're a software company. We write software that enables you guys to do configuration management. Our business is not running email. Our business is not really running version control systems. Our business is not running customer relationship management. So we leverage things like software as a service to enable us to concentrate on our core business. And because we're outsourcing it, what that enables us to do is concentrate on what's important to us, but it also enables those software as a service businesses to concentrate on being increasingly specialized. And I think there are some things that's happened in the software as a service space that has affected the rest of the industry. Because these guys are there and they're offering services, it becomes really important for them to be able to sign up new customers really quickly, for example. So they start to need processes and technology to automate and repeatedly deploy what it means to stick a new customer on our email infrastructure or create a new organisation, GitHub, all those things. So I think software as a service has done a lot to build the capabilities around automation. And the money for this eventually ends up coming from enterprises. So it's the enterprise that ends up funding the building of all those thousands of applications that enable you guys to run your networks. This is where Puppet Labs then fits into it. So Puppet Labs is driving down the cost of technological change by delivering our software solutions for configuration management. So the original version of Puppet, I think it was called Blink, was originally authored by Luke Knies, Puppet Labs CEO, about 8.5 years ago. And it was driven by some of these trends that we've seen here. So the wanting things to be better, the needing things to be better, the wanting things to change, and the fear that the tooling was never going to improve. Originally, I think Puppet was actually run as a plug-in to CF Engine to be able to introspect systems closer, and it's grown to the tool that we know it as today. And the hope of Loop at the time was that widespread adoption would spur sysadmins, so you guys, me, everybody in this room, to think about the toolings and the processes that we're using to drive things. So we're principally a data center and cloud automation company. The target for Puppet and Puppet Labs is principally for server operating systems. It started out mostly as a Unix tool. If you pay attention to the Twitters and the Microsofts, you'll have seen yesterday that Luke actually keynoted at the Azure launch. And there's an awful lot of buzz around Puppet now expanding to non-traditional places for it. So we're not just about Unix, not just about Linux, but also for Windows, increasing adoption of Puppet for that, but also other devices. So things like Juniper routers and switches, Cisco routers and switches, F5 load balancers and that kind of stuff. It's built on top, so you guys have got the books, you'll catch up with this, on top of a very simple language. The language is, I like to think of it as a modeling language, and what we're doing is using this language to describe the desired state of what our systems should be. So in this case, what we're doing is basically saying this is how we manage SSH. There's a package that we want to install, there's a file we want to manage, and we want to manage it to have a specific set of configurations in it, and then there's a daemon on the back of it. And using the language, we can build relationships between these resources, manage the whole thing as a discrete entity, do it in the right order with dependencies. So when we install our SSH, we get it done in the right order. So this is the classic design pattern for Puppet, or the package, file, and service pattern. And that's what we're using at the lowest level to build up our configurations. And the way we use it is using the language. We have this is a diagram showing us the life cycle of systems using Puppet. And it's the writing of the code that, as you look at it, is the top left piece here. So that's the definition stage, where what we're basically doing is going about defining what the state of our system should be. And that's using the Puppet DSL, that modeling language. Because it's a modeling language, and because fundamentally what we're doing is describing our systems in the context of data, that gives rise to some really interesting, exciting possibilities. And this is one of the things that was most important about Puppet when it first came out, because we're modeling systems in terms of data, things have attributes that we can test. Gives rise to the Puppet no-op mode that we can use to simulate what's going to happen when I run this code against the system. That's grown significantly, I think, since off the back of just no-op mode into a whole set of testing and life cycles of what happens before we then actually end up applying those configurations to systems. So simulation is more than just no-op mode. Simulation is all the unit testing and acceptance testing that you can potentially do to your systems before you start making changes in production. I think Gareth's talk this afternoon will cover that in more detail and should be very interesting. So the enforcement step here, that's when we actually end up applying our configurations. So based on the resources that we've written in the DSL, we apply those to the system and test those configurations, apply them. And the final stage, which is really important, of what happens after. Was that run successful? What changed? And that really tells us an awful lot about what's happening in our infrastructure when we apply a catalogue based on a Puppet run. So this is telling us now the state of our production systems in terms of the things that we care about. And then you move on. So this is a never-ending cycle. It's not just one Puppet run and then walk off. Managing your systems, a never-ending cycle of applying change and making sure that any unmanaged change that happen are managed back. Within the context of an individual Puppet run, there's a few other things that happen. So we have the centre here demonstrating the authentication and authorization level within Puppet, which is based on a PKI, so SSL certificates. Within a single run, what happens is the node wraps up some facts using a library called Factor. Some interesting things happening about that at the moment. And sends the state of its environment, so things like IP address, host name, and that kind of stuff, up to the Puppet master. The Puppet master then uses that code we've written. So remember the previous slide, class SSH. It's going to use that code and some classification to work out what configuration classes should be applied to a particular system and send that state back to the node in the form of the catalogue here. Node is going to apply that catalogue, so check the state of all the attributes and all the resources in order, apply that to the system, and then send the report back to the Puppet master where we do something. And this is one area that I'm personally fairly interested in. Is what happens at the end and what we do with that information. So historically, it's been possible to do things like just archive those reports and sit on them and do nothing. But there's some really interesting things that you can do with the data that comes out of here in terms of alerting, in terms of then triggering orchestration events on the rest of the network. So, the architecture of Puppet. So, we're primarily talking about an agent-master-based communication. So, we run a daemon on a node that talks to some infrastructure in the middle. So, we have a Puppet master which is responsible for compiling the catalogue and the security piece and also doing the reporting. This slide is also showing at the top one of the other interesting things about Puppet, which is the community collaboration side of Puppet modules. So there's a thing here described as the Puppet Forge content marketplace. Has anybody got a module on the Forge? Who's got a module on the Forge? 1, 2, 10. This is the place that if you've written some code that you want to open source, to share with other people, And the point of the forge is that it is unlikely that you're encountering a new problem with a bit of technology. It is likely that somebody else has encountered that problem before. And the forge is one of the places you can go to check to see whether or not somebody has encountered that problem and do something about it. I'm going to talk about Puppet Enterprise for a few minutes. So Puppet Enterprise is Puppet Labs' commercial offering for content management and data center configuration management and data center automation. It's a solid platform. So it's built on the success of Puppet Open Source and the other projects that Puppet Labs curates. And it's built up of around 40 to 50 open source packages with some commercial additions on top. The idea behind it is that it gives you the ability to not only scale your Puppet configuration management infrastructure, it also gives you the ability to rapidly and quickly implement Puppet in your networks. And the fact that it's commercial and supported, and we make support promises about it, the 2-year support agreement, means that you can rely on the compatibility of those APIs based on semantic versioning. It gives you access also to obviously commercial support. Also gives you access to people like me. So unless you're running a Puppet Enterprise, the consulting agreement is that the Puppet Labs won't necessarily consult on it. So it's worth thinking about it from that point of view. But we also have technology partners based all over Europe and around the world who are able to enable you to achieve success with Puppet Enterprise. So the additional features of Puppet Enterprise that you gain access to are largely driven around workflowing and being able to introspect the information that you get out of your infrastructure using Puppet. So this slide is showing a partial screenshot of the event inspector that was introduced in Puppet Enterprise 3.1. So this is a feature of the Puppet Enterprise console. What it's enabling you to do is introspect more closely what's happening on your systems in ways that we weren't able to do before. So you can drill down the changes that are occurring on your network based on which classes have changed, which configuration classes have changed on which nodes. You can see which nodes have got changes on them. You can even drill down at the resource layer to see within a period of time what's going on your network. And we also have the live management feature of Puppet Enterprise built on the Puppet orchestration engine. And what this is going to enable you to do is, as well as having, so Puppet primarily is concerned with configuration management. So this is the thing where we're going to write our Puppet manifest, declare what the state of our system should be. The orchestration engine is a thing that allows you to trigger ad hoc jobs on your network. So in this case, we're looking at a screenshot of how you might think about triggering Puppet runs. So you've made a change to your configuration code, and you can use live management to trigger Puppet runners on certain nodes. And it has a powerful filtering ability, so you can filter based on node names, facts, and configuration classes. It's not just about orchestrating jobs. What we're also allowing you to do is, so the interface gives you access to being able to browse the state in a live, synchronous way of what the state of your network is. So this particular screenshot is showing you us having looked at groups on all our nodes. So you can see that all these groups are present on the system, and you can use it to start building up some auditing capability on your network. How consistent is my network? And you can use live management to start thinking about doing it. We also have some built-in cloud provisioning support with VMware. So this is a command line tool that enables you to interface with your internal VMware cloud infrastructure to easily be able to script the building and destruction, turning on and off of virtual machines. enable you to get up running really quickly with private clouds in an automated fashion. In terms of Puppet open source, so I mentioned that Puppet Enterprise is built on top of the success of the open source projects that Puppet Labs runs. So things like Puppet and Factor and PuppetDB. I don't want to talk for a couple of minutes about the implications of the obvious tension that there is then between those open source projects and the commercial software. So with the commercial software, we're required to make some promises to you around, for example, things like support. And those promises therefore imply that commercial software has to have some stability. The tension here comes between us needing to do some experimentation, to deliver new features, and find out what's happening from what the community's needs are around that open source software. And really what that means for us is that the open source projects increasingly are becoming a technical proving ground, a place for us to be able to run experimentation in terms of those features that are required. Those of you who are involved in the community and the mailing lists will have seen the first-hand evidence of this last night. So Eric Sorensen, the platform owner, sent out mail to the Puppet users and Puppet dev lists. So Puppet 3.5 was released last night, the open source version. And that has all sorts of interesting features in it. And those features are available sometimes in the commercial version of the software. It lags behind a certain amount when we're reasonably certain that the version of Puppet open source is going to be supportable enough for us to backport it into Puppet Enterprise. So what we see in Puppet open source 3.5 are an awful lot of interesting features and functionality that are optionally turned on. So I remember a couple of years ago talking to Ken Barbo. I was on a train in Amsterdam, and he was raving about these things called structured facts. Ken, what's a structured fact? And it is the ability to have more interesting and hash data and arrays returned by factors of Puppet. And Puppet 3.5 is the first version of Puppet open source using the future parser that actually has proper support for those structured facts being returned by factor. And so what we're doing is using the open source projects as the place where we can implement those features and those sets of functionality to then eventually they'll make their way into the commercial software. So Henrik Lindberg has been doing an awful lot of work on the future parser. And this is really the thing that's made all that possible. So a lot of these optional features are only actually accessible by explicitly turning them on and changing the code paths that Puppet uses internally. And then eventually, assuming that those features reach maturity, that they hit acceptance within the community, and that they work and they're performant enough, what happens is maybe they'll get turned on into the default. So eventually, for example, structured fact support will be turned on by default. Stuff like iteration is another example of where we've used Puppet open source as the technical proving ground to figure out whether or not features are useful and how those features should actually be implemented. So the feature of the Puppet DSL, where you're able to iterate on arrays and hashing things, was a thing that the community was asking for a long time. And eventually, via the future parser, we turned on an implementation of that. Another feature of the way we did that was not just turn on the possibility of having it, but give a few different options of how the syntax of that might look in the DSL. And so we used the open source project, garnering feedback from the community to figure out what the best way of actually implementing that feature was. And I think that was an incredibly successful experiment. So we're using the open source projects as the place where we can potentially make mistakes, but prove beyond doubt where the proper and best features are going to be. And so it's in open source where we're doing a lot of the bleeding edge development on the core components of the Puppet ecosystem. So not just on Puppet, but again, PuppetDB and Factor and those other core components. So what do those components look like and what do they give us? So we're spending a lot of time talking about Puppet. So Puppet is the thing that gives us that core language, that DSL, the modeling language that enables us to describe what our systems should look like. And it also gives us the transactional layer underneath it to be able to enforce that desired state that we're expressing through the DSL. And we do that through a thing called the resource abstraction layer. So if you've ever written any Puppet code, you'll be aware that there are things like types of resources, so package and file and service and user and group and cron and so on. And that forms the type part of the resource abstraction layer. We also have the provider layer, the thing that actually ends up implementing those configurations on the underlying system in an idempotent way. And we do that by testing the model we've been given against the current state and converging those configurations if appropriate. I mentioned the forge before, so the fact that we're able to express those configurations in a portable way, so via a Puppet module with some codes and templates and facts and functions and types and some files, it gives us access to the ability to be able to share those configurations with other people in the community or other people within your organisation. That's Puppet. So that's the core thing within the ecosystem that's doing most of the work around configuration management. But there are other core components as well. So M-Collective, which is actually largely written by the platform team based here in London. So that's our orchestration offering that's driving the orchestration engine in Puppet Enterprise. And what that is an orchestration framework based on a simple RPC type layer. So what that enables us to do is drive those parallelized jobs across your network to either trigger things or do discovery on nodes and what they're doing, what their configurations are. And again, it's extensible. So you have the opportunity with M-Collective to build your own entirely custom orchestration tasks for fixing your applications or driving your infrastructure, dropping things out of load balancers, adding things back in load balancers as you will, based on Ruby. One of my personal favourite projects, and this is because I'm a stored config exported resources junkie, is PuppetDB. PuppetDB is interesting for a few different reasons, not the least of which is that this is kind of the first major project that came out of Puppet Labs not to be entirely based on Ruby. It's actually based on Clojure and runs inside the JVM. What PuppetDB is the name might imply, a database for storing all your configurations, all your inventory data, and all your reporting data as well, with later versions, I think 1.5 and above, stores reports. And what we can use PuppetDB for is a centralized endpoint for setting data and then querying it later on, so discovering what there is to know about your network. One of the things I mentioned, so exported resources, I love these things, they're absolutely magic, is it gives you the ability to be able to share configurations between nodes. Because we have a centralized store of data, when I'm compiling a set of configurations for one node, I can query PuppetDB and get back a configuration for another and use that within my own set of configurations. So the classic pattern here is to use it to build automatic monitoring. Build a system, classify it. It tells the rest of my network, hey, I've got some things that need to be monitored. And then over here, when my monitoring system is again configured by Puppet, we import those configurations and ta-da, magic. I don't have to worry about configuring Nagios or whatever you happen to be using to make sure that my brand new web server that's just gone down is monitored. I love Puppet, it's magic. Other projects, and again, so Factor is a thing that there's a little bit of excitement over recently. So we've been talking about Factor 2.0 for pretty much almost as long as I can remember. And last week, it was released at last. So Factor is the thing that's at the core of the inventory service within Puppet. So Factor is a library that Puppet uses to be able to introspect systems and then tell your centralized configuration management bits of environment data about itself. So stuff like IP address, what the host name is, how long I've been up for. And it's extensible. So you can write your own Factor extensions that provide custom bits of information about your infrastructure. So your application, you need to share a bit of information about it. Factor's the way to do that. So the exciting thing about Factor 2.0 as it released, and I will keep on going on about it because I love it, is the support for structured facts. So up until Factor 2.0, facts were just key value pairs, and the value was going to be stringified. Now, so the combination of Factor 2 and Puppet 3.5 with the future parser means that you can write those facts that provide you structured data back, so arrays and hashes and arrays of hashes and hashes of arrays. And that's quite an exciting thing. And that's only possible because of the way that we drive those open source projects. Many of you will be using Hira. Hands up who's a Hira fan? Everybody, pretty much. So Hira is the means that we're separating data from code. It's not really a separate project anymore. So Hira is now integrated fully into Puppet. So with Puppet 3 came data bindings based on the hierarchical lookups provided by Hira. So that's now really part of core Puppet. And Razor. Who's been waiting for Razor? Yes. So interesting, exciting things about Razor. So Razor is our provisioning engine. So for bare metal provisioning operating systems, either to bare metal or virtual systems. There's an interesting history behind it. For those who are familiar with Razor, it was originally written as a collaboration between Nick Weaver, who at that point worked for EMC, and Nan Liu, who was a Puppet Labs business development engineer. And the really interesting thing about Razor is that it was written under the umbrella of EMC, and so the exciting thing about that is that they allowed Nick to open source that software and give the curation of it to us. And over the last 2 years, we've been taking that code, making it production ready, and there's now, so as a Razor preview built into Puppet Enterprise 3.2. Again, it's an open source project, so you're more than welcome to download it from the site and use it. So it's really, really clever stuff. So what it enables you to do is build rules inside Razor that you tell your infrastructure how many things of a certain type of it. So using the Factor libraries, you can say, right, if a thing has 8 gigabytes of memory, 10 terabytes of disk, and 4 CPUs, then put this image onto it. But only do that 4 times. The next 4 should be another thing. And by the way, if you get one with 16 gigabytes of RAM, then it should be thing Z. So Razor is a really powerful provisioning engine for putting operating systems on bare metal in Puppet Enterprise 3.2. So how do we interface with the community in terms of soliciting feedback for what these features should be, what's good and what's bad? So up until recently, so the Puppet armatures were the way we did this. So we had a repository on GitHub where we asked people to stop, collaborate and listen on the documents that we had there in order to say, I'd like this feature, I'd like that feature, this feature doesn't work, I'd like this feature to be like this. We've slightly moved away from armatures as being a GitHub repository. We're now experimenting with Google Docs as a way of getting those contributions from the community in terms of what those features should look like. But it's been a partial success in, certainly we've found out that the community is still very interested in integrating with us in terms of the things that they want. So I've talked about the Forge quite a lot. So that's our module repository for finding content that's already been written. If you are interested in commercial support for modules, another thing that's happened recently is that there's the idea that there are now Puppet Labs modules that we will offer commercial support for. And again, they can be found on the Forge. So what about Puppet Labs ourselves? As you can see from the picture, generally speaking, we are a group of people that like to sit around, eat and laugh and drink coffee. If you're not familiar with the man himself, this is actually a picture of Luke. Oh, no, this is a picture of Peter and Richard in our London office. We tend to find that all the pictures here get a little bit Portland-centric, so I've been a little bit subversive here. You will have seen on the introductory slides earlier mentioned, I wanted to talk about this a little bit, about where Puppet Labs is in the UK. So when I joined 2 years ago, I was one of 4 people, so 2 PS people and 2 engineers. We've actually grown to the point where we're now kicking on for, I think, about 20 people, with sales functions, pre-sales engineering, professional services, and software developers. And in a very exciting move, on Monday this week, we moved into our new office in London Bridge, which has taken an awful long time coming, but a thing that we're very happy about. And what that means for the community is anybody a member of the Puppet London user group that we started? Yeah, I'm sorry we haven't had very many meetups. I've actually been waiting for us to have the space in London to be able to run these things. So now we're there, I think we should expect to see a much shorter cadence of sorry, Time Machine just told me it wanted to do a thing. There we go. A much shorter cadence between those community events happening. We have customers everywhere. I always like that we have NASA as a customer. I like the thought of our software sending things into space. Actually, isn't it quite a lot? Compulsory slide at these events. We are hiring. We've just actually opened another position in London for a professional services engineer. If anybody's interested in working in professional services, come and talk to me about it. I'm probably a reasonable resource to do that. Fairly shortly, I think we're also going to be opening a position for like junior sysadmin. So based on the fact that we've now moved into an office and we actually have infrastructure, that's a position that we'll be looking to fill fairly shortly. So in terms of you guys being involved in the community, all you guys are doing the right things. You've come to at least a community event here. But there's stuff you can do online as well. So I mentioned earlier on the Puppet users and Puppet dev lists. For me, those are pretty much compulsory reading for understanding what's going on, the kinds of problems that people are seeing. And the Puppet dev list is particularly interesting for finding out what features are coming along and also getting help. So this guy here, Lee Lauder, he was a community member for a long time out in the US, and the support guys were so impressed with his community contributions that we ended up actually employing him, which is kind of cool. Get trained. If you're not getting trained today upstairs, we offer public training courses and private training courses where appropriate. And all over the world, people love that training. I think I've trained in every single country on the right-hand side of that slide. I think most of that is me. And there's also online training. So if you want to self-paced learning based on a website, then have a look at the website and do that. Puppet Tech Pilot Program is your opportunity to participate in the user research. So this is a program that you can join and get early access to the things that we're thinking about internally, both for open source and commercial projects. So finding out what's going on and giving your feedback on those things. we run quite a lot of Puppet test pilots at things like PuppetConf as well, so all the questionnaires and things that we do there. And speaking of PuppetConf, I know Dawn's got a ticket. I think we're giving away a ticket, right?
Brianna is, yeah.
Brianna's giving away a ticket. What are the qualifications for giving away the ticket?
Give us a business card.
Give us a business card. There you go.
We'll do a drawing.
Okay, cool. So PuppetConf in San Francisco in September. Register or submit a talk for that. That brings me to the end of the things that I wanted to talk about. And I think we've got about 10 minutes. I'm happy to take questions. Oh, that was a quick hand. Yes?
Yeah. Please, something's on my mind. Puppet and mobile operating systems, do you think there will ever be an agent for Android, or is that, or iOS, is that just way too far?
Will there ever be a Puppet agent for Android? I certainly wouldn't rule it out. I know people have done slightly skunk-worky things with running Puppet on JRuby on Android before. I've heard conversations about it internally. I would not be surprised eventually if there was one. Yeah, I mean, ask on the mailing lists if you're interested in finding out if there's any art for it. It's not a thing that's particularly mainstream, which is, I guess, why you're asking about it. Thanks. Yeah.
You mentioned Juniper and Cisco configurations. Does that run on the switches?
So the question is, how do the Juniper and Cisco integrations with Puppet work? So there's a bit of a history lesson here. So there's a thing called Puppet device. So in the good old days, the way that we talked to devices that couldn't run a Puppet on it was basically to have a system that understood how to run Puppet and then some integration libraries. So it basically ran like a proxy. So with Cisco Nexus, I think like 3,000 and up, and specific versions of Juniper 12 and up, Cisco and Juniper themselves have both written integrations whereby in their management domain, it will actually run a Puppet agent. So these things then look like fully fledged members of your Puppet infrastructure. So you don't need to go through the device piece. So Cisco and Juniper themselves have done those integrations, and they've written the type and provider code and the factor libraries and stuff. So they can actually, so it does now with modern devices and modern versions of the management software, it runs on the devices themselves. Yeah.
With Docker, this new technology, how do you see Docker and Puppet working together?
How do I see Docker and Puppet running together? So my experience with Docker is fairly rudimentary, but you still need some way of doing the configuration inside the thing. I know Tom has different ideas on how containers should work. It depends, I guess, how long-lived they are. If you're just creating them and then throwing them away, it's still perfectly legitimate to use Puppet to do the configurations inside the images on the container. If they're going to be long-lived, you still need to do configuration management on them. I don't think Docker in any way, shape or form is going to be a replacement for configuration management at that kind of level anyway, no. So yeah, you still by all means run Puppet inside the Docker container. It just depends what your needs are. Oh, yeah, another back.
Factor 2, about
Yep.
the external facts. Will it be possible to reference from external factor facts? Like, because in the 1.7 it's not possible to reference the fact of using external.
So how factor 2 and external facts work together? So a bit of history again to explain what's going on. So the factor extensions are usually a bit of Ruby that you would ship with a Puppet module. And there is support within Factor for being able to run things that are not Ruby, so stuff written in Python or Shell or whatever it happens to be. That's a thing that actually Puppet 3.5 open source will help you with. So Puppet 3.5 open source gives you the ability to have then a facts.d directory in a module that will then do the plug-in sync of those facts. So what that gives you is the same thing with Ruby facts. So those factor plugins ship on and then run on the same Puppet run. So that's the fix for that. Yeah, I mean, there were some workarounds for that previously, but it wasn't terrific. Yeah, so 3.5 and 2.0 is the combination there. Yeah.
Does Puppet have any collaboration with the distribution maintainers?
Does Puppet have collaboration with distribution maintainers? Yeah, by and large, I think we have good relationships with them. We certainly do work ahead of time with the distribution maintainers around security vulnerabilities and stuff like that. I know Michael Stonke has really good relationships with people in those communities. Yeah. Okay. But I mean, there are occasions where I know like the Ubuntu repos were like miles and years behind.
Because that's the problem, for example, in Debian stable or even newer versions, that those packages are coming quite late, and I'm particularly myself not in favor of using out of distribution software, because it'd be like building the whole distribution yourself. And I was thinking that the support could be slightly better, or at least alternative repositories offered.
Yeah, I mean, dealing with latency of us releasing software and that software ending up in downstream repos is a problem. We don't hide the fact that we release software. In fact, I think we're quite open about it. But I mean, I guess people, I mean, Debian stable is well known for kind of going the enterprise Linux way and being a little bit out of touch. The solution there, if you want the more modern versions, is going to have to be probably running your own repos, really, if you want the leading edge. I mean, we do have relationships with those guys, but we can't really force them to update their software because they've got commitments to other people about what ends up in their repos.
Okay.
Yeah.
Any plans to make Forge available to those who want to host a private repository?
Any plans to make Forge available for those who want to host a private repository? I think there are some open source projects that I know Eric Darling from Spotify has released a private Forge implementation. It's a thing that we're thinking about internally as well as a thing to follow. Yeah, there are definitely thoughts about it, but there are no implementations out of us yet. If you want to do that sort of thing, it's possible to kind of fudge it, so using tools like R10K and module metadata in Puppet files and things, you can kind of emulate that kind of stuff. So run internal version control systems and just bolt a front end on them would be a good solution for that in interim. Yep.
How far are you integrated within the satellite replacement for Red Hat? Because as far as I know, Catella will replace satellite, and that contains Foreman, and Foreman contains Puppet.
So how integrated are we with Catella? Yes, totally. I mean, they're using Puppet open source, and I'm not sure what version of Puppet open source they're using. The last time I checked that, it was a 2.x version. So again, you might see the problems here around what versions of Puppet open source end up in Catella and how customizable that is. Offhand, I don't know the answer to that question. Any more questions? Yes, John.
At PuppetConf last year, I saw a guy demoing some platform providers for provisioning cloud servers in a fairly agnostic fashion. At least that was the dream. Is that anywhere further down the line? What's all that?
That is still very much on the card. So John saw a presentation, I think it was Jack Leslie, who has some types of providers for, so basically a cloud module of being able to drive, so Amazon and GCE and Azure, from being able to model systems in the DSL and use the DSL to bring up machines in those clouds and tear them down. That effort is still ongoing. I haven't seen it recently, but I know we were talking about that a lot internally.
I couldn't find it last time.
No, it might be an internal repository. Yeah, but it is ongoing. Yeah.
Would that sort of functionality not be provided by Razor?
Would that function, so would the thing that we're talking about not be provided by Razor? So Razor is a provisioning tool, so fundamentally thinking about a thing that's sitting and listening for Pixie. rather than a thing that's actually triggering VMware or Azure or whatever to spin up a machine and then build it. Yeah, so I mean, Razor fits into the provisioning lifecycle at the point where you want to stick an operating system on a thing rather than when you want to bring a thing up, really. Oh, yep.
Puppet and Windows.
Yes.
Stuff that works on Windows, but there's a lot of things that you actually work quite hard to make work. Is there much internal focus on developing that?
There's external focus on. So, what's the integration look like between Puppet and Windows, and how mature is it? I think I kind of agree with you that the Windows support is a little bit behind the Unix type operating system support, but that's just a question of time. So I think I mentioned while I was talking about Luke keynoting at the Azure launch. So Microsoft themselves are describing Puppet as being the heart of Azure for configuration management. So Microsoft themselves are standing behind Puppet as being a thing to do configuration management on Windows. So we have internal developers, so Rob Reynolds does a lot of work around Windows and managing Windows. And with, I think, the new publicity from yesterday, I think it will gain traction very quickly. Yeah, last question. I saw this chat first, but I think I'm last question, otherwise I get shouted at. Yeah.
Sorry, it was just a follow-on question.
Yep.
I'm looking at Public Forge, the modules you do support for Windows. A lot of interesting things are actually third-party modules, PowerShell provider, Chocolatey provider, and so on.
Yeah.
Are you thinking about maybe making those things that you support directly yourselves, so you can actually guarantee them?
Okay. So the question is around the module support for Windows on the Forge. And what does that look like? And the two examples you gave, so PowerShell, which was written by Josh Cooper, who works for us, and Chocolatey was written by Rob Reynolds, who also works for us. And what does the support for those look like? You're right, they're not part of the commercially supported module set. But depending on what those look like, eventually they may well make it into the Puppet Labs namespace. And that's happened with other community modules as well. So that the Concat module is now curated by us. Chris Price's AnyFile module is now curated by us. It depends what that story looks like over time. But in terms of those two particular modules, I mean, they are pretty well supported modules for community ones. And yeah, they're fairly well written and they have tests. So, which is what we think. Yeah, so I think we're in reasonably decent hands with those two in particular anyway. Cool. I think that is all I have time for. Thank you very much for listening. Has been a pleasure.